Hello students, in this video I will be discussing Lab 5. In Lab 5 you would be introduced to fillets, something which you have covered in as part of 2D drawings, also revolving in order to generate or create solids, dimensioning, creating profiles, and most importantly covering section and slicing of 3D solids, and finally hatching. So I will leave it up to you to understand and study on your own fillets and revolve as covered in the lab manual for MM101. Now fillets are very similar to 2D fillets, as in for 3D objects you will be filleting edges, and in 2D objects you are filleting corners. So pretty much the command works in the same way. And when it comes to creating solids, so you at the moment or currently you would be aware of creating solids from 2D polylines or 2D objects by using the extrude command or extrude button. And then there are others such as revolve. Now what revolve does is it creates a 3D solid by sweeping about a axis. So normally if you have objects which are symmetrical about its longitudinal axis, such as maybe a water bottle, so you could just define or create a edge or a curve for a bottle and then use and revolve that edge or curve about the longitudinal axis in order to generate a bottle. So I would encourage you to go over this on your own, and similarly you can also create solids by using the loft command as well as sweep. Sweep function is quite easy to execute, as is shown here in the example from AutoCAD, that you need to specify two things. Number one, the 2D object itself and the path. So in order to create 3D solids using the sweep function, first you need to have a 2D object and define a path along which you would be sweeping the said 2D objects. So it's a two-step process and quite a easy way to generate a 3D solid. So here I have a object which we can see it's I've changed the visual style. So let's assume that you were given this view and you are asked to maybe create a orthographic or draw the orthographic from the given view. Now it's important to understand that you need to see, okay, we are assuming that there is this hollow cylindrical shape right at the center of this 3D solid, and does it go all the way through, or does it terminate somewhere in the middle, or is there any other things happening? So to illustrate that, if I just change the visual style to 2D wireframe, so now you can see it looks totally different from the internal cavity for this particular 3D object, right? So here it is handy to understand how sectioning works. Okay, so you can, what sectioning does, it does not actually slice the object, but it creates a section plane, so that you can understand, okay, that this is a section plane. So if you are asked to draw the sectional view, okay, so first obviously you will define a section plane, and from which you will generate the sectional view or the sectional orthographic view. Now there are multiple ways to section an object. I will not be going over all of those, so just a few maybe. So to section an object, in the command prompt area you can type in section, and it will ask you first to select the objects which you'd like to section. So once I have selected that, okay, then by default you would be given the option of selecting 3 points. Okay, if I would like to section this object, along the or parallel to the YZ plane. So I will select my 3 points, 1, 2 and 3. Okay. So there you go, and the section plane has been created. It's that simple. Okay. So it doesn't, as I said, it doesn't actually do any, or doesn't make any difference to your drawing. Only thing it does, it adds a section plane. So it doesn't slice your object, that is separate to sectioning. So we have created a section plane which is parallel to the YZ plane. Now that is using the 3-point method of sectioning, which is quite straightforward. Now also, if you'd like to section parallel to the XY plane, say you want to create a section plane which is horizontal. So after you execute the select section command and select your object, then you can choose the option of XY. So it will ask for, so the next command which pops up is saying to specify a point on the XY plane. So let's say if I choose the midpoint and create a section plane which would be horizontal or parallel to the XY plane. So I'll select that, and now I have a section plane which is parallel to the XY plane. So similarly, you could create a section plane which is parallel to the XZ plane as well as to the YZ plane. And another interesting option for sectioning is the view. Okay, so the current view is southwest isometric. Now given that view, it will say specify a point on the current view plane. So if, let's say, if I select this corner here, and you will see that with respect to the view, so the section plane created is going to be parallel to my view or the direction of view. Okay. So that's how the section command works. Now you have multiple options, so feel free to explore some of those. Okay. And the easiest way to section an object is using the 3-point method. So you just select 3 points and then create a section plane. Okay, now moving on to slice. Slicing is very similar to section. The only difference is that slicing will actually slice your object along the plane which you specify, whereas section, it does not slice, it just creates a plane. So if we execute the slice command, let's try the same. So it says to select the objects to slice and then specify. So again, by default you have those same options or similar options: plane, object, surface. In surface you have to create a surface. In other words, like you create a cutting plane using the surface option, then you can specify that surface as the cutting plane and then slice the object. Okay, let's go with the 3-point method first. Okay, specify the first point on plane. So it's my first point, second point and the third point. Okay, now after this there is another command which is asking you to specify a point on desired side, or which side would you like to keep, or the option is if you'd like to keep both sides. So if you click on that you'd like to keep both sides, you'll see that the object has now been sliced according to how you define the cutting plane. So now I have 2 halves. So if you want, you can delete either half, or you can just move it away from each other. So now you can see my object, or my 3D object, has been sliced. Obviously after slicing, then you have to hatch. Okay, hatch indicates the surface which has been sliced. Okay, in our case, if we ignore this half, okay, then we just concentrate on this half, the right hand side, then we can hatch that. So we'll type in hatch in the command area, and then the dashboard will change reflecting the hatch command. Now what you'll see is that if I try to hatch, obviously I will have to hatch these two surfaces which are vertical, but hatching always looks at the UCS. So now the UCS, in other words, it will look at the XY plane. So in other words, remember that hatching is done parallel or along the XY plane. So obviously the two surfaces I would like to hatch, they are parallel to the YZ plane. So I will have to reorient my UCS so that the two surfaces are parallel or in the XY plane. So I will type, so the surfaces I would like to hatch are parallel to the XY plane. Now I can start my hatch command by typing in the command area. So the pattern we will use for MM101 is ANSI 31, and then in order to select the areas to be hatched, you click on pick points, okay, making sure that the surfaces you are hatching are contained within the XY plane. So that's the first surface and that's the other surface. Once you have hatched the appropriate surfaces, you can close the hatch dialog box. So there you go. After slicing, I have successfully hatched my 3D object. Now let's go and see another example of slicing. Now this time what we will do is create a plane and use that plane as our slicing plane. Okay, so what I will do is first I will reorient my UCS so that the top surface is contained within the XY plane. There we go. So now I will select polyline to create a surface. So the midpoint and the center and the midpoint of the other side. So I have a polyline here. I will extrude this polyline to create a surface. So in other words, what I am doing is I am slicing so that I would delete 3/4 of my object and be left with just 1/4 of my 3D object, and using the surface here as the slicing plane. So I'll execute once again the slice command and select the object to slice. Here you will select the 3D object and not the surfaces which you just created. So select the 3D object to slice. That's done. Now from the option I will choose surface. So I have created my own slicing plane, so I will choose that. So select the surface. Now I will select that surface because that becomes my slicing plane, and quite easily my object has been sliced. So this time select the object to keep. So I would like to keep just 1/4 of my object, so I will select that, and you'll see that automatically the rest of your object has been deleted. I will also delete the polyline. So now I have two sides which I need to hatch. Okay, so firstly the side I need to hatch, that is parallel to the XZ plane. The other side is parallel to the YZ plane. So before I even start hatching, I will have to again reorient my UCS. So I will bring it here. That's X, and I'll make that Y. Okay, starting off with my hatch command. So pick points. Okay, that side has been. Now if you see it, if I want to hatch the other side, which is parallel to the YZ plane, so it does not allow me to do that. All it does is every time it will hatch parallel to the XZ plane. So I'll delete that. Okay, So once I delete, all the hashed areas are deleted. Okay, so probably start it again. So hatching that side, and once I'm done, then I will change my UCS once more, so that that surface has become or is contained within the XY plane, and then I can hatch that with points, and now it looks appropriate. So the two surfaces which were in contact with the slicing plane, they have been hatched appropriately. So that's how you create section plane and slice and hatch your objects. Now students, let's move on to another important discussion for today's lab, which is profiling or creating profiles. So let's just take you first to layers. So if you go to format and find layer, you will see that currently you only have the base layer, which is, the name is 0 layer, and the line type, it's continuous line, and the color is white. So this is the layer which you are using to create all your drawings. So color means the color of the lines. Now there is no other layers available at this stage. So again, if you go to the dashboard right towards the end, that's the only layer which is available. Okay, it's in 2D wireframe, the visual style. So the reason we create layers is to separate the hidden lines and the visible lines, so that we are able to distinguish or differentiate the solid lines from the hidden lines. Okay, so what we will do is create profiles. So two profiles will be created of your object, which is a visible profile and a hidden profile. So here, obviously, what you can do is, if you change the visual style, you'll see that, and if I select hidden, so only you are able to see all the lines which are sort of behind the object, those are hidden. Okay, so this is just the visual style. This is not the correct way of profiling your drawing or creating the visible and hidden profiles. So what needs to happen first is you need to set the page for your layout. Okay, I have already done that in my case. Okay, I am going to use this, so probably I need to change the visual style. Okay, and for solid profiling to work, you need to be in the layout, okay, not in the model space. So if you try, the shortcut for solid profiling is solprof, SOLPROF. If you type it while you are in the model screen, it will say you must be in a layout to use solprof. Okay, so we will go to the layout. Right. Now within this, I will type in solprof. Then it will say select object. So I will select my object. Once that is done, okay, you will be given a set of questions. Okay, so display the hidden profile lines on a separate layer. Yes. So in other words, we will keep our original drawings, and a separate layer will be created where the hidden lines or the hidden profile will be created. Okay, so you would like to have that, so you'll click on yes. And the second question which comes up is project profile lines onto a plane. So we will click no, because currently we would not like to project lines onto a separate plane. And then finally, would you like to delete tangential edges? Okay, so in this case you will click on yes. You will see that At the moment you will notice that nothing is really happening to your drawing, but once you go back to your layers, format and layer, you will see that two other layers are created, which is PH. PH stands for hidden profile and PV means visible profile. Okay. Now at this stage what you can do is maybe for the hidden profile you can change the line type. Okay, so go to format and look for line type in order to load that particular line. So you can load hidden lines from the library, so hidden x2, and now it's loaded as part of your line type manager. Okay, so you can go back once again to layers, and where PH is, you can see the line type is continuous, so change that line type to hidden. Okay. Now still you are not able to see anything, but if you move the cursor over or the crosshair over, you'll see that that's your, you can see the information provided in the box which just pops up. It's a block reference and the layer is PV, so that's your visible profile. You can click on it to select. So what happens, the layers which are created, which is the hidden layer, the hidden profile and the visible profile, they are sitting on top of your original drawing. Okay, so you need to move it away from your original drawing. So I've just selected the visible profile, and now whatever is behind, that's my hidden profile. So I'll selected that as well. Now I will move it away. Okay, so there you go. Maybe I'll have auto turned off. So on the left here, that's our original drawing, and on the right hand side we have our two profiles, our visible profile and our hidden profile. So now because we have changed the line type of our hidden profile to hidden lines, you can see that they are shown in hidden lines. So that's our hidden profile, and this is where we have our visible profile. Now you can use layers. So you'll see that there's a bulb icon. So if it's in yellow, it means that that layer is turned on. So we can go and turn off the hidden profile. Okay, so click on that bulb icon, you'll see that. Okay, there you go. So now you can see that the hidden profile, which was visible just a while ago, has now been hidden. It's not been deleted, it's only been hidden. Okay. And if you want, you can turn it on again. Similarly, you can turn off the visible profile if you wish to. Okay, but as part of your Lab 5 exercise, you will be drawing, creating your 3D solid and then creating solid and hidden profiles using the solve prof command, and then just turning off the hidden profile while leaving the visible profile turned on in layers. And so that's how solve prof command works. So far in this video we have covered section, we have covered slice, and we have covered hatch, and also just a while ago we have covered or understood how to create profiles of our drawings, solid and hidden profiles. So before ending this video, I would just quickly like to touch on dimensioning. So I have already set my dimensioning format according to whatever we had discussed in our lab class. So the way dimensioning works, or 3D dimensioning works, is AutoCAD likes to dimension parallel to the XY plane. So the top view here for this drawing is currently contained, or it's parallel to the XZ plane. So if I'd like to dimension any of the sides which are in the top view, you'll see what I mean. So let's say if I want to dimension that side, you see what happens? It's always looking for the XY plane. So the dimension, it says 0 because it is looking, so that 0 is parallel to the XY plane. So what I will do first is reorient my UCS so that the top view, which is currently in the XZ plane, is changed and it is in the XY plane. So UCS. So the top face, I would want that to be in the XY plane, so I can just select the face option, and now I have my top view of this 3D object contained within the XY plane. So then I can start to dimension. Linear dimension, that same edge. Okay, so there we go. Right, so that's 50. We'll see another difference if I just change the positions of the X and Y axis. How does it affect the same dimension? You see what I mean? So you see the difference between the two dimensions, and so the side which you like to dimension, ensure that it is parallel to the x-axis, and the surface which you like to dimension, ensure that it is contained or it is parallel to the xy plane. So I'd like to give you as a hint while dimensioning 3D objects. Okay. So this first one is the correct way of dimensioning. So I will delete this second one. Okay, similarly, if you would like to dimension the left hand side of your drawing, so currently the left hand side of your drawing is contained within the YZ plane, so you have to reorient the UCS so that the left hand side view is parallel or contained within the XY plane. So I have done that now, and I can start to dimension it. Okay, so yeah, that is how dimensioning works for 3D objects. Just a slight difference when compared to dimensioning 2D objects, but it means the same thing, because in 2D your drawings were contained within the XY plane, hence it was very straightforward to dimension. So while dimensioning, always remember that the side or the surface you are dimensioning, check whether the UCS it is within the XY plane. So that's it for today's video. I hope this would be helpful in completing your exercises on 3D. And if you would like to understand more, it's explained in quite detail in your Lab 5 manual. So I encourage you. So remember, we haven't discussed anything on 3D fillets as well as revolve commands, so you can read through the Lab 5 manual and try those on your own, which are quite straightforward and simple. Thank you for your attention.